everyone, welcome back to Let's Unbound. We are in ninth episode of the series, Inverse Trigonometric Functions. So let's explore. Be ready with your pen and paper. Here we go. So what is this inverse trigonometric function? We know how to find inverse, right? For many function inverse exist. And for sine also, we are trying to find inverse, sine cos, like trigonometric functions also, we're going to define the inverse of it. So how it behaves, so like normal trigonometric function will take angle as an input and give you a ratio. So it's like sine pi by 6 is half. But inverse trig ratio, I know the ratio, but I need the angle. So this case, I need inverse trig, right? So you have a ratio, but you need angle. Inverse trig is, the need of the inverse trig is here, right? So let's see. Sine, you can, the inverse, you can write it arc sine or sine inverse x. The notation is angle whose sine. So we have, the answer is an angle whose sine is x. Okay. Cosine or cos, you can denote, or cos inverse, angle whose cosine is some x, that ratio. And tangent or tan inverse of x also, angle whose tangent is x. This is what the meaning and the notation. Now, inverse of sine. Actually, inverse means what? I will reflect my original function with respect to y equal to x line. For example, your y equal to x line goes like this. Okay, I will reflect this. If I reflect, like your sine function is something like this, right? It will go from here to here to here, and it goes on and on. When I reflect this, it will be something like this. I rotate it, but when you reflect, it is something like this, right? So when you reflect, after reflecting the whole sine function, it will not be one to, like it will not be a function actually. Why? Because it can't pass the vertical line test. If you have this wave structure, at one moment it will meet the graph at many points, so it will not be a function. So entirely you can't define a trig inverse sine. But let me take some, because it's periodic nature. Of course, every periodic nature will have repeat pattern. So when we rotate this, and we got that problem. So now I'm going to take it from minus pi by 2. So actually the mathematicians just look which part I can take and define inverse, so that even if I reflect it, it will still be a function, right? So they took minus pi by 2 to pi by 2, this particular part, and then we are just reflecting this one. So when you reflect, it will be something like this. Okay. So, and you can clearly see this is sine function. Your domain is like angles in radians, and your range is 1 minus 1, the maximum. But here the domain becomes minimum minus 1, maximum 1, and range becomes pi by 2 to minus pi by 2. Right? So this is how we restrict domain, and we got inverse. We are not doing the inverse. We can't do the inverse for the entire domain. Right? So this is sine, this is inverse of sine. Right? And here we go. Inverse of cosine. So cosine, how can I find? Cosine is also like repeating pattern, something it will go like this, but it won't start from origin, it will be. So when you reflect this, again, it will not be a function, right? So we have to restrict the domain, but here I'm restricting the domain from 0, like this 0 to pi. This only I pick, and I can define inverse for this. This is called principal value. We are not, it might be possible in many other, but I'm taking where my origin lies, right? So even you can take this pattern will repeat after like 2 pi to 3 pi also. Yeah, I can find the inverse if you take this range. But my principal value, right? I'm picking 0 to pi. Where your origin lies, I'm picking that particular branch and finding the inverse. So this cosine part I'm taking, it's 0 to pi, and range is minus 1 to plus 1. And also you see, after you flip this, like if you reflect this, you got something like this, right? Reflect means what? Like if you have 0 comma 1, it will change to 1 comma 0, right? if you got pi comma minus 1, it will be 1 comma pi, right? Sorry, minus 1 comma pi. So you just flip the values and plot it, you will get this, right? And this is cosine first is, second one is cos inverse. We restricted the domain from 0 to pi. Now inverse of tangent, I take one branch and when you just reflect it over a line y equal to x, like 0, 0 will be 0, 0, and this will be something like this, right? So here the domain restriction is from minus pi by 2 to pi by 2, okay? And when you see the domain and range values got shifted, because we are flipping xy is in your original function, means yx in the next function. I mean inverse function, right? So sine inverse, the domain is minus 1 to 1. Range is, this is principal domain, okay? Principal value minus pi by 2 to pi by 2. Tan inverse also, the range is minus pi by 2 to pi by 2, but it goes from domain is minus infinity to plus infinity, no restriction on that. And cos inverse is from minus 1 to 1, but your range is 0 to pi. Okay, your range will be angle in sine, like inverse trig functions. Now evaluating inverse trig. So sine inverse of 5 you have. So to simplify something like if you want sine x, or you can take sine on both sides. This will cancel out and give you the 5. This manipulation we can use. Sine inverse will get cancelled because inverses will cancel, right? Sine arc sine or arc sine sine, cos arc cos or arc cos cos. So these will cancel and give you the inputs. Okay, this we might use at some places. Now, let's go for a question. What is the value of arc sine root 3 by 2 and find the principal value in radian? So they are asking sine inverse root 3 by 2. I need to find the angle. Okay. So when I see the root 3 and 2, let me make a right triangle. And root 3, 2, I think you can connect this and 1. This ratio is connected with 90, 60, 30, 60, 90 triangle. Opposite to this, it's 30. Opposite to root 3, it's 60. So root 3 by 2, like I'm finding an angle, let it be theta. So sine theta is root 3 by 2. Okay. So in this you find some sine 30 is 1 by 2. So I need root 3 by 2. Let me find sine 60, which is root 3 by 2. Right? So that theta is 60 degree. But they're asking in radians. Radians means you just multiply by pi by 180. It's pi by 3. So pi by 3 is the answer for this. Right? And this is that simple it is. And we have to make sure if they ask in radians, we should give it in radians. Right? And here we move to the next part. So the principal value. And also you have to check whether it lies in your principal domain. So sine inverse, I mean the range, right? Sine inverse of x, the range is minus pi by 2 to pi by 2. Right? Why is the range is? We have to check whether your values falls on that. That is important. And moving to question number 2. Evaluate this one. So we have to see here, it's cos, cos sine inverse 5 by 30. So let me work out what is the sine inverse 5 by 30. Okay, you can draw the triangle and let me put x is equal to sine inverse 5 by 30. And what I will get? Sine x equal to 5 by 30. Okay, let me put x here. Sine x is 5 by 30. This is 5, this is 30. And I should find this. Okay, so it's square root of Pythagoras theorem, square root of 13 square minus 5 square, 169 minus 25, 144, which is 12. So this is 12, or if you know it as a Pythagorean triplet, then it's so simple. Okay, then this is my, this x. So, okay, so now I can write this as cos x, correct? Because my x is sine inverse 5 by 30. So what is cos x from the diagram? Adjacent by hypotenuse 12 by 30. Now let me replace my x. My x is sine inverse 5 by 30. which is 12 by 30. That's simple. It seems like complicated, but this is the way we can manipulate using our techniques. Right. Now, question number 3. This is important. Find the inverse of this and state the domain and range. Maybe let me name it as f of x. So first, you take f of x as y and 3 sine x plus 5. Then, how we did inverse for the previous functions is very similar. Swap x and y. X becomes y, y becomes x. So x is equal to 3 sine y plus 5. So take the 5 here. Now make y as a subject. X minus 5, 3 sine y. And divide by 3. 3 cancels. Sine y is x minus 5 by 3. And y is sine, when it shifts, it will go sine inverse. Sine inverse x minus 5 by 3. So this is your f inverse of x. Sine inverse x minus 5 by 3. Right? Now we need to state the domain and range. So what is the general domain? So y is equal to sine inverse x minus 5 by 3. This should lie between minus 1 to plus 1. Correct? So this is the input. It should lie between minus 1 to 1. So minus 1 less than or equal to x minus 5 by 3 less than or equal to 1. Let me find x. So multiply by 3. 3 cancel is minus 3 less than or equal x minus 5 less than or equal 3. Then add 5. X less than or equal to 8. This side it's 2. So domain is from 2 to 8. This is the domain. Okay. Then range. Y is sine inverse x minus 5 by 3. And whatever, if it's sine inverse z, if you take, we know the range is going to be minus pi by 2 to plus pi by 2. And the same for, sine inverse z. So it doesn't affect any output values. All the transformations, like x is changed to minus 5 by 3, it's not affecting the output values. So range is as same as the parent function. Okay. And sometimes they will ask in interval notation. So it's closed interval 2, 8 closed interval. Closed interval negative pi by 2, positive pi by 2 closed. Right. That's simple finding domain and range and also inverse of function. Right. And I have a bonus question to you. Find inverse of minus 5 cos x minus 5. So this is cos x like this. Take a screenshot and state its domain and range. Right. Very simple and an easy topic, but it plays an important role when we solve a problem in an exam style way. Right. And that's the wrap for today's video. I hope this video helped you. If yes, you can like, share, and subscribe to Let's Unbound. And also you can join Let's Unbound student community by scanning the QR code given here. Thank you so much. Keep learning. Stay curious.